Let's discuss the heat transfer through a spherical cell. Let's assume you have a spherical cell having inner radius Ri, outer radius Ro, and the thermal conductivity of shell is K, and inside wall temperature is Ti, outside wall temperature is Tu. Okay. So we know the Fourier's law equation for heat transfer is Q is equal to minus Ka delta T by delta X. We are studying this equation from a starting onward, and for this particular case, let's see, if you have a very tiny shell, very thin shell having radius R, and temperature gradient is delta T for this particular thin shell. So we can write this equation for this spherical cell. This will be Q is equal to minus K A dt by dr. Why? Because in this case, if you are changing the radius from Ri to Ro, temperature will change. So let's assume this Ti is greater than To. In this case, heat will transfer from inside surface to outside surface. Okay, and this cross section area is also changing with respect to change in a radius. So again you can write Q is equal to minus K 4 pi r square dt by dr. We need to integrate this equation with respect to limit r varies from Ri to Ro and temperature T varies from Ti to Tu. So let's rearrange this equation again. So r square 1 by r square dr is equal to minus K 4 pi by Q dt. So let's integrate Ri to Ro and temperature Ti to Tu. So integration of 1 by r square is minus 1 by r. Then we put the limit minus K 4 pi by Q, integration is T to Tu. So now after putting the limit 1 by Ro, this minus plus 1 by Ri is equal to 4 pi K by Q minus this is Tu minus Ti. So now final equation will be Q is equal to 4 pi K Ti minus Tu by 1 by Ri minus 1 by R. You can rearrange it again. So now Q is equal to 4 pi K Ri Ro Ti minus Tu Ro minus I. So this is the final equation for heat transfer through a hollow shell.